All right, I'm going to talk about perfectly fine-tuning your own sparse lexical expansion model in about 5 minutes. All right, there's a few simple steps. First is index your documents into your inverted index. And second, you're done. Your index is a language model and is perfectly fine-tuned to itself, your data. That's binary, by the way. There's 2 steps. If you like amazing AI-powered search techniques like that, you might want to check out this book. I hear it's got some cool stuff in it. But in reality, actually, so we do have a language model that's our index. But the question is, okay, fine, it's a language model, but how good is that language model? So I'm going to compare it to Splade, which is the most well-known sparse lexical model, to see how it looks. I'm not going to go into all these different ways of doing, dense and sparse search, mixing them hybrid, all this kind of stuff. I'm just going to focus on the 2 pieces down here under this term expansion piece on the sort of sparse lexical side, semantic knowledge graphs and Splade. Semantic knowledge graph, the 30-second overview. In your index, assume you've got a Lucene index, for example. You've got an inverted index, which maps terms to sets of documents, and then you've got a forward index. This is doc values in Lucene. This maps documents to sets of terms. If I can go from a term to a set of documents, and from the sets of documents to terms, and from the terms to sets of documents, you get the idea. I can traverse many levels deep. This is a graph called a semantic knowledge graph. Over here on the left, this shows you an example. I've got a field called skill. I'm searching for the skill of Java. I find a set of documents. From those documents, I traverse or do faceting or analytics to find other terms. This is a set theory view. This is a graph view. I'm traversing a graph that is my inverted index. It is my language model. Why does this matter? For purposes of modeling intent, if I have a query called barbecue near Haystack, you can see down here on the right that I can traverse that index from terms to documents to find other related terms. And I can even go from terms to a category, and from the most semantically related category to other terms. So I can expand barbecue to something like barbecue or ribs or brisket or pork within the category of restaurant. If I type in the query barbecue grill, semantically, barbecue now has a different meaning. It's barbecue or grill or propane or charcoal in the category of outdoor appliance. This is all being done just with my inverted index, no dense embeddings. This is my language model. Now, talking about Splade, if I use this semantic knowledge graph approach I just showed you, it can determine that barbecue is a doc type of barbecue with these terms for an expansion. If I use Splade out of the box, no fine-tuning, again, my index is perfectly fine-tuned to my data because it is my data. If I look at Splade, I get BB, grill, barbecue. Okay, that's kind of sort of at least one of the meanings, the wrong meaning, but one of the meanings. Dish, restaurant, sport, food. Okay, let's look. Here's the code, by the way. Here I'm generating the Splade embeddings, and here's the code for the semantic knowledge graph embeddings. It's all from the book. But here's some examples to show you the difference between using a model perfectly fine-tuned to my data, i.e. directly using my inverted index, versus using Splade out of the box. Korean barbecue, category Korean, term vector, Korean barbecue, banchan, sarawan. Korean barbecue for Splade, Korea, BB, grill, dish, restaurant, Kim, food, dinner, Japanese, eat, hotel, no, not looking good. Lasagna, Italian, lasagna, Alfredo, pasta, Italian, from my inverted index. Over here, Splade, lads, ag, nah, okay, comma, what? She, species? Festival, company, genre, okay, whatever. Drive-through, fast food, drive-through, McDonald's. Window, I didn't get the color right. Drive-through over here. Through, drive, great, driving, pass, drives, through, driven, enter, pierce, into, transport, clear vehicle, route. Okay, you get the idea. This works in the sense that it's going and matching some terms in vector space, but this over here is perfectly fine-tuned to my data, required no training of any kind of a transformer model. It's literally just using my inverted index, and this works super well, so you should try it out. It's in the book. If you'd like to learn hands-on, Doug and I are giving a training course in November. There's a 25% discount code. Grab it quickly, because I probably have like 10 seconds left, and that's pretty much it. Would love to spend November with you. And that's more about me. Hopefully that was interesting.
Thank you, Trey.
Thank you.